Hello and welcome to another free code session. My name is Jason Bach and I woke up, I went to bed last night, and now I have a new day, hopefully a better mood. Last episode, I did not end in a good mood. I was getting very frustrated with this and source generators in general. And I still stick by the thing I said, which is that this is just, it is too much work. This will never, in my opinion, will never get as far as it could if it isn't made to be easier to create. I get that there has to be some level of complexity to this, but it feels, you know, we haven't even touched I'm using Humanizer and I got to figure out how to get that package to come over as with the analyzer, you know, and then or with the generator. And then if you want code to be accessible to people, you have to like emit that code out first as strings. It's like, this is ridiculous. You know, I'm ranting again. I need more coffee. So, but anyway, I did get off camera a solution because for some reason in this piece of code here, we are turning nullable warn as error, which should make sense. But again, I'm looking at this code going, I have no idea why this is erroring out. It should not. It just shouldn't. There should be no reason why this is coming out this way. But what does end up happening is this does pass. So now we're in a better position. So what I'm actually going to do is change this to be a file scope namespace and change this to use well, no, I can't. That I can't do because again, in this stuff, it only works with, like if I come over here, no, not that here, reference assemblies, because they haven't updated this to be, to work with .NET 6. So until that happens, or I look at the code here and see what they've done to create that getter here, I've got no chance. So again, this is where this so I guess now that I think about it, I'm going to leave this be, but I am going to put a note in the generator to say, no, not in the builder, because that's where we're doing something. Here, to do. Once the testing packages have ref assemblies for .NET 6.0, we can change the gen code to be file scoped namespaces, as well as what's the other thing I want to do? Oh, as well as use argument null exception dot throw if null. Okay, I put a semicolon at the end. That's funny. All right, but another thing I just thought of, and I realized, and did I get an answer to this? Hold on. Okay, I did not get an answer to this. I put this in the Discord. One thing I realized is if you have only one out parameter, you can make a deconstruct. In fact, did I put this in console F6? Yes, I did. I made a struct somewhere. Where did I make that? In class here? No, that was my extension. Yeah, here. I made a record with just one property. And so like if I say IL spy here, and I say, what are you actually generating? What it will do is it should create a deconstruct with one, which is fine. But how do you call that? Like, you're not deconstructing into multiple. So like you can't say here you have stuff and then I want var s stuff ID is equal to stuff. Well, that's just going to assign a reference to that. It's not going to actually call deconstruct and deconstruct the value out and in there. The only way it seems to work is if you actually literally call deconstruct. So yeah. So I was thinking last night, do I put in a rule that says you have to have at least 2 accessible properties? No, because a record will, as you just saw with IOSpy, a record will actually produce a deconstruct with one out parameter. It's just that you as the caller now would only be able to deconstruct it explicitly this way. And then you could like say, like if I delete that and I say console.writeLine SID, and that would be fine because that is a string. Okay, so that works. So I just talked myself out of undoing something, which I'm going to keep it as is. If I have to generate 1, I'll do 1. And like I said here, if I have 1, I will just do a little literal assignment, like this equals this. Otherwise, I'll do it as this kind of tuple assignment, and that works as well. So if I come back over to my tests here, I should have, this should be succeeding, right? This should be succeeding now. If it isn't, we'll figure out why, but there's nothing that should stop this from succeeding. God, I hope. And then we can move on. Yeah. Just take the sweet time, that sweet test time when I'm recording. Did you, are you running? Okay, so you pass. Okay, so now it passed. So we're good. Okay, so now we're making progress. Okay, so let's now build some more tests, okay? So we want to do this with a value type, okay? So up here, no, I keep trying to figure out what is the, no, that's not it. I don't use that keystroke enough where you can, there you go. Okay, yeah, it's some combination of Control, Shift, and Alt. It's Control Alt, and that lets you skip around. There, value type. So now we're going to make this a struct with a string, and the only difference should be here is that we just do that. Okay. So we don't do any weird assignments, and then up down here, let's move to that and say value, change this to a value type, make that a struct. And then again, this null check should go away. Okay. And then let's just keep going. Let's make where we have a record, because that actually should do nothing. So we should have here generate with record. So if we say here like public record test string ID, generated code should not do anything. Okay, so we should say here, what is this? This is a enumerable of that empty. So no, you're stupid. An enumerable empty of whatever this is supposed to be, but IntelliCode is not type string string. Okay, so it should be a type string string. In other words, nope. Oh yeah, we need to put that there. In other words, we don't produce any diagnostics, but we don't produce any code either, because we should not be doing something when we have a record. And you pass. Good. That's actually what we expect. Okay. I didn't check. I could just do Control-Alt-A. Oh yeah, you're always bound to a command, aren't you? You're always bound. But I can do that, and that actually works because reasons. I don't know why. So all those pass. Okay, so that's good. Let's put in a test with no accessible properties. Okay. Actually, let's just copy this code because that's a little bit more along the lines of what we are looking for. Generate with no accessible properties. So in this case, We do want it can be a struct, it doesn't matter. But all these are private, which seems really stupid, but allowable. And this should do nothing because we can't actually generate a deconstructor this way. Deconstruct this way. Well, I always want to say deconstructor, but that's not right. Perfect. Perfect, perfect, perfect. Okay. We should start putting in tests for if there's an extension method in play. Oh, before we do that though, let's do the tests where there is a deconstruct on the type, but it doesn't match or it does match. And then we'll go from there. So let's grab one with multiple. So we'll do that. And we'll do that. You didn't grab everything, did you, Jason? Come on. It's not that early in the morning. There we go. So here we want to say generate with no deconstruct match. So in other words, what we're saying here is test has a public void deconstruct, where it has an out string, where we can say out int value out string name, and we'll keep it simple in that value name is equal to this dot value this dot name. Okay. The point is we can do 3. So we should still see a deconstruct come out like this. Okay. Again, the order doesn't matter. We're not looking at the overload rules. It's literally by count. And that works. But now what we're going to do is where we do have a match. Yeah, so let's actually do this. We'll put this code here. This ends up being, these classes end up being rather large. Generate with matching. Oh. Matching. Deconstruct. Is that what I... Yes, that works. Okay. So I want to put this code in here, except this is going to actually have the out GUID ID. And so we'll do the right thing. ID this dot ID. Okay. And this should give nothing because it already has one that matches by the number, not overload, but the number is correct. The order doesn't matter. None of that matters. It's just by the number of out parameters you have. So we should not do anything in this case. Oh, oh, shiver me timbers. That was disappointing. What's the problem? So it actually did generate a source. Well, that's not good. Okay, but we have this magical debugger thing that we can do. So if we have a type declaration, it's only if the method declaration do we dive into it. And it wouldn't come through here as a static because it's just a void. So we don't, that's good because we don't have to worry about those. So let's put a breakpoint here. And let's do that. And somebody is texting me. Or somebody's buzzing me. Or however you want to say it. Yeah, I know. my internet account, I just bumped to having unlimited download data. Because I could never hit the cap. They put that cap in place a year ago or so. It's kind of annoying. But if I just put in the extra whatever it was, $30 a month, and then I don't have to worry about it. But of course, this month it's still saying, well, you're over. Which fine, whatever. Okay, so we do have a type. We do have test. I did it again. I hit F10. I finally looked within the tools in Camtasia, and there's a way to turn off, like, I guess F9 actually pauses it, which is interesting because if I was putting in breakpoints, I was pausing it. Maybe, possibly, I don't know. I've never noticed it in recordings, but F10 definitely stops the recording. So now if I hit F10, it just steps over, and it doesn't stop the recording. So yay. Okay, so that makes 3. Well, that ain't right. Oh, wait a minute. It is right, because we're literally trying to find the number of accessible properties. Now what we're trying to do is we're saying if the length is greater than that, let's see on the current type. Say like to array, just to make it easier. Gets that. And we do have a deconstruct here, so it should find 1. Okay. So we say the name is equal to deconstruct. Deconstruct. It isn't static. It will return void. The parameters count where the ref kind is out should be equal to the parameters length. So in other words, it's the same number of parameters. They're all outs. And that length is equal to the accessible property length. And then we should not have any methods by the type key where 1 less is equal to the accessible properties. Okay. Now this should pop out, but what it's doing is it's popping in. So it's not. So what we have here, we have 6 to array 6. Okay. What's its name? Deconstruct. Deconstruct. Well, if you want to, that would explain it. It's not actually the right deconstruct. So it was actually doing the right thing. It was making a deconstruct because there wasn't one that followed the rules. So good on it, And it passes now. Awesome. Okay, so the test was wrong. Okay. We want to have here one that just has something like you have you have 3 parameters, but one of them is not an out. So let's say that with existing deconstruct, but with parameters not having ref kind as, but with non-out parameters. It doesn't read very well, but we can have here like a int values like that. Okay. So this should still generate 1. It's a parameter that we're ignoring in the body of the method. We don't care because it's just test code. But we do want to see a deconstruct kick in that actually follows the right rules. There you go. Because this method is actually not a deconstruct method. It doesn't follow the rules. Okay. So I think we're making some really good progress here, which is good. Of course, I forgot how long the recording was when I stopped it. I think I was at 10, roughly. So, yeah. Okay. So we haven't done the whole there's an extension method existing already type of thing. So we need to have tests in there. What about if you return void? Yeah, I think that's another one we need in our tests. So let's do this. We'll increase the parameter count so it actually equals but we'll say it returns void with deconstruct returning void, not returning void. So we'll say here it's an int. I'll have it return a value in just a moment. Return 3. We will say here this is, so it will match all the value name ID is equal to this dot ID. Return 3. This should still create one because this is returning an int. Though this is going to get into an interesting case here because I'm going to have a static method that is an extension method. And which one would C# call? So before I run this test, since I have my trusty console app 6 up here, let's actually do this. Let's just throw in a public int value get set. Let's do string ID here, out int value. So now we'll do ID value is equal to this ID and this value. Okay, let's get rid of all this stuff here. Var test is equal to new test. Value is equal to 3. ID is equal to 3. Now let's do var ID value is equal to test. Console write line ID value. Okay, run this. 3, which is what we expect. Okay, let's get rid of this crap. Now here's the interesting part. If I come over to my class 1 here, and let's say we have a string. So, oh yeah, we needed the nullable. Fine, whatever. So we're going to copy this, and we're going to paste it in here. And then we're going to do this. Okay. And then we're going to do that. And then we're going to do this. Test self. Okay. And now these are self. Okay. Great. That's awesome. So which one is it going to call? Because both of these should be in available usage, right? So, and this is like saying this is a valid deconstruct. So let's say ID is going to be +3. Now what's it going to do? Yeah, that's what I was about to, right as I was running, I'm like, I should guess. And my guess was going to be, it's going to take the one on the type, not the extension method. I believe in this case, this is like an overload issue, sort of. And so it has to resolve to 1. And it's going to pick the one that's on the type definition first. However, if I change this to an int, okay, and now let's make this block body, and we'll do that, and we'll say return 3. Well, now this is interesting. It doesn't know what the deconstruct is. Even though we have that in place. Oh boy. This is something I tested. It should work. See, now it does. Okay, if the name of the method here gets changed to not even being deconstruct, then it's like, okay, as soon as I make that a T, Let me look at the error again here. No suitable deconstruct instance or extension method was found for type test T with 2 out parameters and a void return type. Well, what's this? 2 out parameters and a void return type. I don't see what the problem is here. I don't see what the issue is here. And you do have a using here. And if I do take this off and I run this, it's going to 33. Yep, and that works. So don't tell me you can't find it. This is an interesting case where, because this return is messing it up. Now, if I took that off, now it should work, right? Yes. And what this should do is give us 33 and 3. Yep, because it's going to call the one that has 2. So there's this, it seems like there's this odd cat. I don't think it's a compiler bug, but it does seem like there's this odd case where if you were going to run into this, where we had 3 that matched, but the return type was wrong, I would say you'd still want to generate this. But what you do have is a weird thing here where, I'm going to stop here for a second and think about this, because this is this bizarre case where this whole deconstruct thing came after C#1. So there are definitely cases where somebody could have written a method called public int deconstruct way before deconstruction was ever a thing and just did it themselves. And then you'd have to call deconstruct manually, okay? And then get the return value for whatever reason. So C# still has to honor that and say that that's a valid definition that should just work. But now if I put in this, I'm kind of messing things up, because like if I think about this, the compiler's kind of saying, well, wait a minute. You have one that's a void and that's actually valid, but it was coming out and saying, no, I couldn't find a valid deconstruct method. And I'm like, no, there's one there. There's definitely one there. Granted, this is a really, really rare case, where somebody would do this. What's the right thing for me to do, though, in this case? And I'm going to think about this for a second, because I'm not really sure. Because I really don't know. This is obviously going to cause, or at least if I'm looking at this again, if I put this all back, and I call that a deconstruct, this is going to start to fail. Wait, let's look at the error. Where are you? Sorry, we don't have specifics on. Yeah. Drunk Roslyn. That's what I call it. So, CS8129. C# CS8129. No, I do not want this. Record deconstruction problem. Use the... Yeah, I've just been scrolling through this. I think what I'm going to do is just post something into the C# channel and say, hey, like the error message is a little weird. It's saying it can't find a suitable one, but it can. But then I think we're honestly hitting this point where, where it can't tell the difference between, I think if I come back over here, it can't tell the difference between this one. Now, let's just play with this. If I change the order around, okay, and that should be fine here. That won't help this. But if I say what I want is a int value and a string ID, yeah, it does. I think you just do that. Yeah, so it still can't find. Even if I'm saying I want the literal order this way, doesn't matter. In value string, that doesn't help either. So I'm thinking if I do, okay, I do need to stop because I want to get some coffee and take a break for a second. But I'm thinking if I actually do run into a deconstruct method that has the right number of, see, then I'd have to special case that though. I don't know. I'm going to take a break, stop recording, Jason, take a break. Let's think about how we want to handle this. So I will see you in the next episode. Thank you all for watching. Leave comments, questions below. See you in the next episode.